This is problem number 8. We're told we have a perpetuity immediate that pays 100 at the end of each year, and we're going to exchange that perpetuity after 5 payments for a perpetuity or for an annuity, a 25-year annuity that pays X, but the payment increases by 8% each year, and that the interest rate for both the perpetuity and the annuity is also 8%. So first things first, let's get the value of the perpetuity immediate at 8% with payments of $100 each year. It doesn't matter that we're exchanging after 5 payments. Could be 5, could be 10, could be 15, could be 500, could be after the first payment. The value of the perpetuity is always the same. It doesn't matter where you start in time. So the value of these two, the perpetuity and the annuity, should be the same after 5 payments, but of course, as I just said, the value of the perpetuity after 5 payments is going to be the same as it was at the very start. So just a clever way of giving you a value to set the second part equal. So we'll come back to this, and we can see that we're increasing by 8% each payment. So that looks a lot like a geometrically increasing annuity. So let's try the formula for that. The present value of such an annuity at 8% would be given by 1 minus the rate of increase over the rate of interest raised to the number of years divided by the amount of interest, or the rate of interest, minus the rate of increase. And you can see an obvious problem here, right? This numerator is going to simplify down to 0. The denominator is going to simplify down to 0. And the constraint that's given to us with this formula is that the interest rate cannot equal the rate of increase. So I assure you the problem writers did that on purpose. Our shortcut formula fails. When all else fails, when our formula fails, we go to the timeline and we look at each individual payment and come up with a new formula. So at time 1, we're going to pay X, but we want the present value of that payment. At time 2, we're going to increase the payment by 8%, and then we're going to discount that payment back 2 years, because we want the present value of the annuity. Time 3, we will have increased the amount of the payment by a factor of 8% twice, but then we'll discount that back 3 years to get to the present value. And let's jump forward in time to year 24. We will have increased the value of the payment by 1.08 raised to the 23rd power, and then we will discount back 24 years. So the offset here is a little bit frustrating, but if you write out each individual payment, that's what you get. So at the very end, we would have increased, we will have increased the size of our payment by 8% 24 times, and then we'll have to discount that specific payment back 25 years. So that really makes sense, right? We have X. The first payment is X. The second payment is the first time we introduce the 8% growth factor. The third payment is the second time we introduce or uses that 8% growth factor twice. So the offset is logical, even if your brain would prefer that those two exponents be the same. I get it. One of the things you just got to learn to roll with on this exam. Okay, so this is a series of payments. Let's add them all up and maybe simplify them. In fact, let's do some factoring, right? We have an X in common on each payment, so let's just factor out the unknown initial payment, leaving us with V plus 1.08 V squared plus 1.08 squared V to the third, and so on and so forth until we get to the final payment, 1.08 to the 24th times v to the 25th. But let's think about what our v is. That's our present value factor, which is just the reciprocal of our interest rate. So let's rewrite this series of payments with v represented as a numerical value. We have x times the reciprocal of 1.08 plus 1.08 over the reciprocal of 1.08 squared. And here we have 1.08 squared over v to the third, which is the reciprocal of this raised to the third power, or rather the reciprocal of 1.08, it is this value raised to the third power. And going on to the very last payment here, we have 1.08 to the 24th over 1.08 to the 25th. So there's a cancellation we can do here on every term. Knock one off the top and one off the bottom. Knock two off the top and two off the bottom. Knock 24 off the top and knock 24 off the bottom. So what we've actually got here is x times 1 over 1.08 plus 1 over 1.08 plus 1 over 1.08, and we have that factor there, 1 over 1.08, or it's really just v. That factor shows up 25 times, one for each year. So we can rewrite it as such. 25 times x divided by 1.08 is the value of our 25-year annuity, and we can set it equal to the value of our perpetuity. And from this point on, we are home free. Multiply both sides by 1.08 and you get 1350. Divide both sides by 25 and you get x equals 54.